method approaching the answer. So we say that the Newton method succeed in solving the problem. Basically, following that line. Okay, I think that's just a highlight. The highline. Now, okay, after true false, there is a multiple choice, but just like the true false, you must explain your answer. Just give a short sentence to to, to explain the answer. So, okay, it will be your first midterm in the university, right? So, how to say? The main difference in answering exam in the high school or before and university is you must know what you want to do. What you want to do is you must, how to say, how you must explain, you must make the professor know that you understand the problem. You understand the problem and can solve the problem. So not just the answer. The answer is number two or number three. So even if the answer is wrong, but the way is mostly correct, you will get some score. Not full score, of course. But if you give a correct answer with no explanation, you won't get any score. Okay. And in university, don't expect that the professor will give you some score if you just write something random. Okay. I mean, in the high school, usually the teacher give like 1 mark out of 20 or 10 for writing some things in the answer sheet. Not in the university. Usually, that doesn't happen. It's just a common knowledge for university student. And there is multiple choice and provide, yeah, just let the professor know that yes, you know how to solve that. So you don't need to write an essay of every answer. You will have no time for that. But let the professor understand, oh yes, this guy can solve the problem, not just copying from his friend. That's the point. Okay. This number 12, everybody can understand, right? How to solve. The inverse of derivative is, Professor Iman has taught that this kind of problem, right? No? Okay, no problem. No, that's derivative of the inverse.
Also, we have to solve for the inverse and then
Have Professor Iman teach about derivative of the inverse? No? Maybe not. Okay, no problem. After that, there is a part that, well, basically you must write everything that is, you must explain every single detail of the answer. Okay, that's neither here nor there, and it is when usually they have the most of the style, so don't miss that. Okay, that's basically all. Okay, if you forget about what is the inverse of the things, okay, basically, let's say let gx is the inverse of x, okay? So what is the composition of g of f equal what? We have a function and then do composition with the inverse of it. It's become what? Become identity, right? For example, fx equal to x. So the inverse of x is what? One. Oh, well, it's hard actually because I think you will be confused. What is the inverse? Anybody in the internet answer it? Not yet. Okay. Okay. Yes. Okay. So actually, the inverse is also x. Get it? I mean, if we draw this is x, this is y. If this is 2, what we get is the y is also 2, right? Yes, yes, yes. Yes, yes, yes. But if fx is, let's say, x plus 5, then the maybe it's not. Wait. How to remove? I forget. This should be f inverse. So you don't. So the f inverse of x is simply x minus 5. But if fx is x squared, then the f inverse is square root of x. Kind of, but not really. Like, yes. So it's because it is not bijective. The function it's not one-to-one, so it doesn't have inverse actually. So it only has inverse if we limit the domain. If x is bigger than 0 or x smaller than 0, then we have the inverse. Otherwise, we don't have the inverse because it's not one-to-one. Now, okay. So what I want to do now? So we have g is the inverse of f, okay? And what we get is equal to the composition of function with its inverse is identity, or let's say 1, okay? 1 equals to 1, okay? Agree? Hey, sorry, no, not 1, not 1. Should be, well, identity. What the identity means is the equals to x. So it's written to the answer. So for example, if the domain is 5, it's mapping to 20. Then if we took the inverse of 20, we get back our 5. Okay? Make sense? Well, that's the idea of inverse, right? You get what originally there. Okay. Now, so we have the composition. So we get back to X. We get back the domain. Okay, basically something like that. So what we do here? So we want to take the derivative of d of g composition of f to x dx. This equal to dx to dx. Okay, because if we derive the left side, we also have to derive the right side, right? Okay, this one equal to. Okay, so the left side first. So what is the derivative of the composition? Yep. Something like this, right? Equals to 1. Wait, sorry. You get why it's 1 because dx over the derivative of x is 1, right? Now, what I want to show you is, so what is the GDF is equal to dx df, which is basically 1 over df dx. So for example, if I have give you a question, what is the fx equals to, let's say, x squared, okay? What is the derivative of f inverse at x equal to 4? F inverse derivative at x equal 4. How to solve this? We know that df dx is what? 2x, right? So df dx at 4 is 8. From here, we get that the inverse, the f inverse of 4, sorry, is equal to 1 over df dx. So we get 1 over 8. Make sense? Or doesn't make sense? I think it quite makes sense, right? I'm sure, I think Professor Iman has taught this, right? No? Maybe.
We talk about this already, but I have never seen.
The inverse.
Yeah, we talk about the inverse at the start, right? But I have never seen such like kind of relations before.
Okay. Oh my God. Sorry. Sorry for the class that it's freeze. I'm sorry. Uh, so what? Okay, sorry for the freeze. Well, basically, what I want to say is, uh, so let so what I just remind you what is the inverse. So for example, if we have fx equal x, then the inverse is also x, because this function happen to be symmetric. So basically what the inverse is if f5 equal to 20, then f inverse 20 should be equal 5. That's, well, everybody understand that. But so for example, if fx is x plus 5, then f inverse is x minus 5. Okay. So if we do composition of f inverse to f, what we get is x, return to the original x. So what I want to tell you is that let's do we composition like that, okay? F inverse and do composition with f, and we get x. Now we want to derive this problem, just like we doing derivative on composition, right? So we have the df inverse df times df dx equals to, we derive left side, we also derive the right side, dx dx. Now this thing is equal to 1, sorry. So what we have is the f inverse of df equal to dx df, or 1 over df dx. So for example, if we have fx equal x squared, what is the f inverse of x equal 1, for example? Now, as you know that x squared is, the function of x squared is not bijective, it's not one-to-one. And if the function is not bijective, so like I check the, okay, so okay, it's not freezing anymore. So if it is not bijective, we don't have the inverse. But if we, sorry, dx. But if we ask what is the derivative of this thing, we can say that df dx of 1 is, well, 2 times 1, because df dx is 2x, right? Equals 2. So df inverse of dx equals to 1 over 2, half. But that's what I want to tell. Sorry. Just okay. Okay. It's how to say, it's easy, but if you forget, then you cannot answer the question. If you don't know this, you cannot answer the question. So let us return to our problem. I mean, uh, last year. Huh? Yeah, last year question. I think we have extremely limited time now, so let us solve some question. I think I don't have time for you to do by yourself, but so I can. I think I have some time to do by myself. So yeah. Okay. Now, let's say we want to solve number 12. I think before you know what the trick that I give you before, you will be confused how to solve number 12. But now, number 12 is quite easy, right? It just what is the fx? Fx is sorry, fx, the derivative of fx is what? Cos x, right? And so f derivative of inverse of 0 is equal to 1 over f derivative of x of 0, and this one is 1 over cos 0, so equal to 1. Now, number 13, can you do by yourself? I think that's let us do together. Hopefully, I'm not forget how to do it. So here we have y equals to tan inverse x power of sin x. As usual, we change into a to the log tan inverse x power of sin x. So it's become a sin x log tan inverse x. And you do the derivative as usual. Sorry. So we have d of dx sin x log tan inverse x of the original things. And this one become cos x times log tan inverse x plus sin x. What is the derivative of this? Over tangent inverse x. And what is the derivative of tangent inverse x? I forget. Okay, so 1 plus x squared, something like this, right? Yes, 1 over 1 plus x squared. So yeah, something like this over the times the original things, times these things. And so what is the answer? The answer will be tangent inverse cos x ln tan inverse x plus sine x over tangent so the answer is D, right? The answer is D. The same one, right? Like this. Well, if I'm not calculate mistakenly, so I think the answer is D. Okay, number 15. Well, so basically there is a woman that there's a that drop a stone and after and 1 second after she drops another one. What is the difference? How fast is the distance between the stone is changing? So basically, what is the difference of the velocity of the two stone? So if these two stone has the same velocity, the answer is what? If the two stones happens to be falling in the same speed, the same velocity, what is the answer of the how fast is the distance between two stones changing? Yes, if 0, right? Because the distance of the two stone doesn't changing. So basically we try to find the difference velocity between the two stones, right? Yep. Okay. So we have D equals 4.9 t squared. And what is velocity? Derivative of d, right? D of d. Oh, 2dt. Okay, we have. Okay. So what we have is 9.8 t. Okay. So we have two stone, right? One's stone 2 and stone 1. Okay. Stone 1 is the one that she first drop, and stone 2 is the stone that she drops 1 second later. So, and we know that for the stone, let's say the t of stone 2 is equal to t. So the t of the stone 1 is t plus 1, right? So at t equals 1, because 1 second after that, how fast is the so 1 second after she drops the second stone, at t equals 1, a in the stone 1, the t equals what? T equals 2, right? For the stone 1, because the stone 1 has been on the air for 2 seconds, right? While this while the stone 2 only 1 second. T equals 2, so we have v equals to 9.8 times 2. Well, for the stone 2, t equals 1. So the v velocity is 9.8 times 1. So the velocity difference is well 9.8 to minus 1. Well, 9.8. Make sense? So, well, 9.8 is basically what? Remember? Gravity. Yes, gravity. Number 16, well, I think you can do that. So basically, you must find what is the inflection point, blah blah, and the minimum, maximum, and something like that. So they say that the graph does not to be accurate in scale as long as all the important point, the asymptote, the inflection, the what the maximum, minimum, the all the extreme point draw correctly. And number 17, I think easy, right? Sorry. Check and yeah. Number 17 is just well. Well, basically we have ellipse, and we have rectangular here. So the area of rectangle is what? I think 2y times 2x, because this if this is x and this is y, because we have x to the right and x to the and this is negative x, and we have y here, positive y, and we have negative y here. So the area will be 2y times 2x, and then you substitute y from this thing, and so what is y here? Y over b square equals 1 minus x square over a square. Y square equals b square minus x b square x square over a square. So we have here a equals to 4 times x times square root of b square minus b square x square over a square, or for b x square root of 1 minus x square over a square. And you do the derivative here, find when the derivative equals 0, and I think pretty much that's it. And you check it is the largest or maybe the smallest. If it is the smallest, there I think there will be, let's say, 2 points, and you check which one is bigger, something like that. Yes. Just you can do second derivative, but I guess I think you just compare is faster. Yeah. I mean, because we are sure it is extreme point, right? It is either bigger or smaller. think, what if you think that second derivative is safe? Wait. I think it's you can just get second derivative maybe because second derivative is not that hard for this problem. I think it's not that hard. So
So the answer and you have to express it in AB, right?
yes, it's for any AB. So the answer will be in AB because it is ABX square root of a square minus x squared. And yeah, so basically the answer will be in AB. Just doesn't need to. I think that's all for today. Is there any question so far? No? Or there's any question from the internet? No? Okay.
Are you going to upload?
Ah?
Are you going to upload the video?
No. Because uh, because Professor Iman didn't give me the permission to upload yet. So
Okay, I just that is kind of his copyright.
yes, it is his thing. Oh, mm, so recently Professor Iman basically said to us the TA that to asking you guys whether or not you need additional class in the weekend. So so I don't know who is the head of because usually there is one leader of the class. Who is the leader of this class?
The
Understand? So because well, I how to say I don't know whether you need that you need additional class or not, but I mean if you need that I can give it to you, but we need to synchron our time. So
How about just make the test, but it's depend if you want to join or not. It's depend on you. Alright.
yeah, that's okay, but I don't know whether our time will be the same if I open.
So how about if you can just follow your schedule.
Mm,
Yeah.
so when you will be free? Uh,
maybe the time that you
okay. Uh, so I think I will ask in the Moodle in the forum whether or not you need to have